Probability examples 20 through 21. Now we're still looking for a number of ways certain events can happen. And so let's carry on with example 20. 8 runners have made it to the finals in the Olympics, but only 3 medals are awarded: gold, silver, and bronze. In how many ways can the medals be awarded? Well, again, we're looking at gold, silver, and bronze. How many do we have to choose from in the beginning? 8. Well, one person has now been awarded the gold medal, and now we have a choice of 7 for silver. Now we've had 2 medals given away at this point, down to 6. So you see that this is not factorial because we're not multiplying all the way down to 1. And I also want to note that order matters. It does matter to the athlete whether or not they got gold or bronze. The order in which they finish that race definitely matters. So there are 336 ways that those 8 runners can finish first, second, and third. We're not concerning ourselves with the 4th through 8th places. All right, B. Suppose 98 people entered a drawing in which 5 prizes are awarded: a gaming system, a mountain bike, a laptop, a $50 gift card, and a $25 gift card. So it's important for us to realize on this one that those are all different gifts. So it will matter who gets what because they're different. Now, keep in mind later on we're going to be talking about how many ways people can be awarded exactly the same prize. In that case, order would not matter. But this one, when the prizes are different, order will matter for us. Okay, so we only have 5 prizes to award. How many choices do we have for the first prize? 98. That prize has been given away. So now they're only, and that person, well, let me see. It says, assuming that each person has entered the drawing exactly once and no one receives more than 1 prize. So that's important to note, right? So that person can't receive another prize. So how many people are eligible for prizes? 97. All right, then that 2 prizes have been given away. And the 96, I think you see where we're going on this. There were 5 prizes, so there we go. So how many different ways can those prizes be awarded to 98 people? So it will be 8,149,303,680. The problems in example 20 were a little different from those in example 19, namely because we didn't continue to multiply from n number of elements all the way down to 1. Instead, we stopped along the way. These are examples of permutations. So there are NPR permutations of size R that may be selected from among n choices. So in your calculator, you might see something that looks like this. And this specifically is how it is figured. So I wanted to refer back to example 20A, where we had the 8 runners. So 8 factorial would be in the numerator. And so that was, the 8 was our number of choices. So in the denominator, we have our number of choices minus the size. So we were looking at 3 ways to finish: gold, silver, bronze, okay? Not 3 ways, but we had the 3 awards. Okay, so that gives me 8 factorial over 5 factorial. All right, let me go ahead and write this out. So 8 times 7 times 6, 5, 4, 3, 2, 1. 5 factorial, 5, 4, 3, 2, 1. Alright, so hopefully you can understand that it's okay for you to reduce these factors here. And you will look, and what are we left with? Well, it's the same way that we did 20A. So I think you can see that these are two different ways of doing the same thing. All right, so some specifics here. Permutations are used in situations where there is no repetition. Generally, the same person does not win the gold, silver, and bronze. And the order of the selection matters. Okay, so think about the door prizes. It would matter what prize they got depending on when their name was selected, right? And then also with the race, it matters to someone whether or not they finish first, second, or third. Well, it matters to most people anyway. So as I alluded to before, if you don't want to use permutations, you can use a basic counting rule, just like we did in example 20. All right, so let's go on to example 21. How many 6-character passwords can be made using the capital letters A through Z if repetition is allowed? So you have to ask yourself, is this a permutation? Well, it says repetition is allowed. So the answer to that question is no. So for this particular problem, we have a choice of 26 characters for each character in the password. So 1, 2, 3, 4, 5, 6. Naturally, you could write that as 26 to the 6th power. And that gives us, I think as you could figure, a big number. 308,915,776. So compare that to B, where it says how many 6-character passwords can be made using letters A through Z if repetition is not allowed. Now this is a permutation. Order matters in a password, okay? So we would write 26. That's how many choices we have. P6, that's the size of our password. So you can just type that in your calculator. I think as you see, the number of choices we have lowers. 165,765,600. All right, I'm having a bit of a problem here in that I did not download the next page. So I'll go ahead and write the answers down here, and you follow along in your notes. So C says among the 18 members on the student council, so that's a number of our choices. So it looks like in this case our N is going to be 18. So among the 18 members on the student council, a president, vice president, secretary, and treasurer. So we have size of 4. It says, in how many ways can these positions be selected? So this is where we have to use our common sense. Does order matter? President, vice president, secretary, treasurer. Well, I'm going to assume there's a considerable difference of serving as a president as there would be treasurer, okay? So this sounds like a permutation. So we had 18 choices. The size is 4. And so when I multiply that out, I get 73,440. Now remember, you could have used the counting rule as well, where for the president, there's 18 choices. Okay, then one person has that position. And then for vice president, 17. So 2 positions are taken by these people. And then 16 and 15. And it'll give you the same answer. All right, and then D asks us, how many ways can the names of 12 people who made the volleyball team be listed? Okay, I think we could all agree that perhaps it's not that big of a deal of who's listed first or what have you. But the thing is, once you write that name down, it's like the children being seated for the picture. Then that name is affixed. They are in position number 1. So order matters, okay? So there are, and we can't have repetitions. You're not going to have the same person's name listed all up and down the roster. That's ridiculous. So on this one, there's actually 3 ways we could do it. Now, it might not be fun. You could write it out. I'm going to pause this while I do that. Okay, aren't you glad you didn't have to sit through all that? Okay, and since order matters, I could do 12, permutation 12. Or since I am saying that order matters, I'm using all 12 items all down the one, I could do 12 factorial. All of these ways are the same, will give us the same end where we get 479,000 millions, 1,600. So let me read that again. 479,001,600.